Good day, I am Pilit from BSE Designs 3B and I'm going to show you how we can easily derive the time dilation equation. We will consider this illustration on the left first. Let us suppose that you are inside a moving train that is traveling to the right at a velocity of v with a height represented by L. You, as an observer inside the train, can of course observe the light beam shooting from point A and being reflected back into its point of origin. Now, if we want to calculate the time for this process that the light beam spends traveling back and forth, we will use the time equation T sub O, which is equal to the product of 2 and L being the height of the train with the beam going up and down represented by that 2 coefficient, divided by C, which is the speed of light. Now, since you, as an observer inside the train, can observe the complete process of the light beam shooting from its original point and returning back to its point of origin, we would therefore call this the proper time. Let us now look at this illustration on the right. This time you are no longer an observer inside the train, but on the ground, observing these events happening inside the train. Because the train is moving to the right with a velocity v, the light beam now has to travel diagonally from point A to somewhere on top before hitting the ground somewhere far from its point of origin. As we have said, the train is going at a certain velocity to the right, so we have to consider a horizontal component of the speed of light, which is the train speed v. For the vertical component, we would consider the Pythagorean theorem, the square root of c squared minus v squared. Now, if you want to figure out the time spent by this light beam for the entire process based on your perspective as an observer on the ground, we would use the time equation T, which is equal to the product of 2 and L, divided by the square root of c squared minus v squared. As an observer on the ground, you have noticed that the light beam released from point A did not actually come back to its point of origin and just landed somewhere else. It has a different starting point and an end point, so we call this time the measured time. To figure out the relationship within these two formulas, we divide proper time by the measured time, and we'll get the square root of c squared minus v squared divided by c, which simplifies to the square root of 1 minus v squared divided by c squared. We could also be more specific. For measured time, we would have t, which is equal to the proper time divided by the square root of 1 minus v squared divided by c squared. For the proper time, we would have T sub O, which is equal to the measured time, multiplied by the square root of 1 minus v squared divided by c squared. And that is how we derived the time dilation equation. Thank you.